Hi everyone, we're starting our next section, which is exercise 10E in the MYP5 text. Now what we're going to be looking at today is we're going to be looking at finding the area of a triangle using sine. Now normally when we are looking for the area of a triangle, we are using the formula area is equal to base times height divided by 2. But what I'm going to be showing you today is that it is also possible for us to find the area of a triangle even if we don't know what the height of that triangle is. So if the height is unknown, how do we go around being able to determine that height, determine that area without knowing the height itself? All right, so what we're going to start doing is we're just going to very quickly go over a concept that is very important, and it's a way of labeling the triangle that you absolutely need to know about. Now, this method that I am using is done for non-90 degree triangles. So from now on, anything that we're going to be talking about will be dealing with non-90 degree triangles. So the SOHCAHTOA that you know, SOHCAHTOA, can no longer be used for non-90 degree angles. This is only for 90 degree angles that you use SOHCAHTOA. So it's only for right triangles or 90 degree angle triangles. And the laws that we're going to be looking at in the next several days are going to be the sine rule, and we'll be looking at the cosine rule. And today we're looking at the area using sine. And these are all different types of rules that are used for non-90 degree triangles. Okay, so non-90 degree triangles, right triangles. Okay? All right, so before getting started, let's just go over the terminology. So if I have a triangle A, B, C, the opposite side of B will be labeled as being small d. The opposite side of angle A will be labeled as being small a, and the opposite side of angle C will be labeled as small c, so that the small letters represent the lengths of sides, okay, and the large letters represent the angle measures. Now, I think it's quite clear that angle A, or rather than writing it in words, it's clear that I think that angle A is always going to be opposite side A, or so the little a there. Angle B will be opposite side B, little b, and angle C will be opposite side little c. Okay, so small letters refer to length of sides, and large letters refer to the angle measures. All right, so having said that, what we're going to do is we're just going to start by doing one thing, which is we are going to derive the alternative formula for finding the area of a triangle when we don't have the perpendicular height. So if we don't have the height, how do we figure out what the area of a triangle is going to be? All right, so how we're going to do this is I'm going to just actually start another page here so that we can do this from scratch. So I'm just going to take this and we're going to put it in a new page, and we'll take this part. Okay. All right, so and I'll make it a little bit bigger. Okay, so this is the situation. What I'm going to do is I have triangle ABC, okay? And what I have done, and what's already been done rather, is that the perpendicular has been dropped from A to D, and so I'm going to call that H. And if I follow the labeling that we did before, if this is angle A, then all of this is going to be side A. If this is angle C, side C will be opposite that, and side B will be opposite angle B. Now, in creating a perpendicular from the angle A okay, to the base of the triangle, I have made a 90-degree triangle there. And what I have here is h for height. Now, if I had to write a ratio or a relationship between this angle and the height, I could probably look at this and just say, well, all right, it's going to be the sine of angle C is really equal to the opposite over the hypotenuse. So it'll be h over b. So I can say that if I isolate for h, I would just rearrange the formula here, and I would end up with b sine of c has to equal the height h. All right, now, having done that, okay, I'm going to take a look at this now from another perspective, because the triangle or the angle that I've used up till now, this angle, angle C, was an acute angle, okay, as I used as my point of reference. But let's assume that the triangle that I'm using is this one here, okay, where I have ABC, so I've done it in pink, but to get the height, the perpendicular height of this, I'm going to have to go outside the outside of the triangle. So I have to go to the exterior of the triangle, and I'm going to get my height from there. So I can say, here's my height. Okay, well, maybe I should do it in green. Here is my height. And again, the h is going to be for height right here. And I still have that angle B is opposite side B, and I see that the angle C internally here is still opposite side C, and angle A is still opposite side A. But externally, I have formed a 90-degree triangle. Now, if this angle internally was angle C, then that would mean that the angle inside, on the other side that forms the 90-degree, so this angle here, it would have to be 180 minus C. Now, if I were to write a relationship between sine of 180 minus C and the ratio of the lengths of the sides, it would still be sine of 180 minus C equals B, is equal to h over b. Now, again, what we see is that h over b seems to be equal to the ratio of sine of C, and h of b, though, is also the same ratio for the area. It's still the same ratio for the sine of 180 minus C. So that if I isolate also in this formula, in this side, on my right-hand side, if I isolate for h as well, I get b sine of 180 minus C is equal to h. Now, because the areas of the triangle have to be equal to each other, then technically I could equate, or rather the heights of the triangles have to be the same. I can equate one triangle, or not equate the triangle, but what I can do is I can say, well, since sine of 180 minus C is giving me the same value as here, it's h over b here and h over b there, then why not just say that the height is equal to b sine C? So I can just say in conclusion that the height really is the same thing as saying b sine C. So whether I say b sine C or whether I say b sine of 180 minus C, I still have the same criteria. I have the same thing going here. All right, so in doing that, I now know that my height is equal to this relationship. Now, when I look at the formula for area, well, area is equal to base times height divided by 2. Now, this base is referring to base. It's not referring to b here, okay? So it's referring to the base, and I'll just put that in red. Now, that's the formula, the regular formula for base times for area, which is base times height divided by 2. Now, if I look at my triangle, though, whether it's the one to the left or the one to the right, my base is going to have a length of A. Do we see that it's A in both of these? It's A across here and A across here as well. That's my base. So wherever there's a B for base, I'm going to substitute it with A, and it'll be A times. Now, the height is now going to be replaced by what we found the ratio to be, because we don't know the height, but we can get the height or surpass the height by saying that it's multiplied by b sine of c divided by 2. And this turns out to be my area formula. Now, I'm going to show you on the next page that I have, I'm going to get my triangle here. So I have the triangle that's like this, and so I'll say again, A, B, C, there's little b, there's little a, and there's little c. Okay, so that what I can do now is I can simply say, well, if I'm going to do the ratios, or if I'm going to do the formula for the for finding the area of a triangle by using sine, so the actual formula turns out to be area is equal to 1/2 AB sine of C, which is the same thing as saying 1/2 of BC sine of A, which is the same thing as saying 1/2 AC sine of B. So what the rule says is this, that in order to find the area of any triangle when you don't have the height, you need to make sure that you have, for example, A, the length of A and B, and the angle between them. So that means this is called the included angle, okay? So you would have to say that the area of this triangle is going to equal one side times the other side times the sine of the angle between them, and then divided by 2, because it's divided by 2. But if I were looking at it from this angle point of view, okay, and I knew that the two sides given were C and A, well, then that would be the same thing as saying 1/2 of side A times the side C times the angle between them times the sine of the angle between them is going to be sine B, and therefore that would be divided by 2. So that would take care of that. And then if I knew this angle here, angle A, well, that means that I would have to take the side C, multiply it by the side B, because angle A would be the included angle between those two given sides, and it would be times the sine of the angle between B and C, and then it would be halved. So the area taken from one angle as opposed to another angle as opposed to another angle is always going to give me the same area. Okay? All right. So I think what we need to do is we just need to do an example. The example certainly helps this somewhat. So by creating, let's do an example very quickly. So here's an example right here, so that we can look at, so we've got 12.6, 109 degrees, and 10.4. I don't really care at this point if it's A, B, or C. All I need to know is that if I'm given a side, which is 12.6, and I'm given also the other side, which is 10.4, those would get multiplied together, as long as I have the angle that's between them, which is the sine of 109 degrees. And then I would divide it by 2, because that's what the area formula tells me to do. So opening up my calculator, all I would have to do then is substitute in 12.6 multiplied by 10.4 times the sine of 109, and I would close the parentheses, and then I would say enter, and then I would divide that by 2. So it would tell me that the area here would be 61.95, or 61.95, which to 3 significant figures would be approximately 62.0, and this was in centimeters, so it's going to be centimeters squared. All right, let's just try another example very quickly. So again, I'm given, in this case, I am given the two sides. It says the triangle has this area, and they want us to find the angle theta. So in this case, we have the area, so it's 24. We set that equal to, well, the length of one side is 8. which will get multiplied by the length of the other side, which is 7, and it'll be multiplied by the sine of the angle between them, theta, which is what we're looking for, and we'll divide that by 2. Now, in doing that, now I isolate I get rid of the 2 in the denominator here, which means that I multiply 2 times 24, which gives me 48. 48 equals 56 sine theta, and now I'm just going to divide both sides by 56 and 56, and therefore sine theta, and therefore I will say that sine inverse of 48 over 56 is equal to theta. So I will go again into my calculator, and I will say, I will do the second function, sine of 48 divided by 56. Now I'm doing sine inverse because I'm looking for an angle measure. So the angle turns out to be 58.9, which is 59.0 degrees to 3 significant figures. Okay. Now, again, this is another question that's similar. Let's take a look at very quickly just finding the area of a parallelogram. So if we have a parallelogram with sides, 12.2 and 8.8, and it has one interior angle of 75, well, the interior angle is referring to the included angle. So I will start by drawing out my parallelogram. So you were not giving the figure here. And I know that one side is 12.2 and the other one is going to be 8.8. Now, if I'm looking at finding the area of the parallelogram, well, the parallelogram can be divided up into 2 triangles. So if I can find the area of one triangle, then I'll just have to multiply it by 2 in order to get the full parallelogram area. All right, and we know that the angle in here is 75. So I can say area is equal to 2 times, because there's 2 triangles, and I'll say 12.2 times 8.8 divided by 2, and it'll be times the sine of 75 degrees, so that I can certainly cancel out my 2's and my 2 here, so that I just get 12.2 times 8.8 times the sine of 75, and therefore, again, using my calculator, I will just say 12.2 times 8.8 times the sine of 75, close the parentheses, equals 103.7, or 104 or 104 meters. Okay, I feel like I should be checking that again. Sorry, something just doesn't seem right. I feel like I didn't put it in properly. So 12.2 times 8.8 times the sine of 75. Oh, that's correct. Okay, so that's it. So we're done that problem. All right. I'm pretty much done here, so the work that needs to be completed is exercise 10E all. Thanks.